All right, so good evening, everybody. Let's go ahead and get started with Unit 7, Lesson 12. If you're wondering why you can't find Unit 11, is because I decided to skip it after looking at the content. So we're going to be using powers of 10 to help us make calculations with large and small numbers. So what information would you need to answer these questions? How many meter sticks does it take to equal the mass of the moon? So if you think about it, how many meter sticks do you need so it weighs the same as a moon? So I think you need to know how much each meter stick weighs. And additionally, how much the moon weighs. Moon weighs. Once you know those two, you can figure out how many you need to fill it in. If all of these meter sticks were lined up end to end, would they reach the moon? So what would you need to know? First of all, it's a meter stick, so you know they're 1 meter long. What would you need to know to see if they would reach the moon? Here's Earth. Here's the moon. If you said the distance, absolutely. The distance to the moon. All right, so how many meter sticks does it take to equal the mass of the moon? Explain or show your reasoning. This doesn't make any sense. We're not given the information here. Bro. Well then, in that case, don't worry about this. If you look at all the meter sticks from the last question and line them up end to end, would they reach the moon? Will they reach beyond the moon? If yes, how many times farther? Once again, don't know, because we don't have that information. 1 light year is approximately 10 to the 16 meters. Remember, 1 light year is how much how much distance light travels in 1 year. How many light years away would the meter sticks reach? That's a good question. That's a good question. So here's a problem that will take multiple steps to solve. You may not know all of the facts you need to solve the problem, but that's okay. Take a guess at a reasonable answer to anything you don't know. Your final answer will be an estimate. If everyone alive on Earth right now stood very close together, how much area would they take up? If you think about it, each person takes about 1 square foot. And you know how many people exist on this Earth? About 7 billion people. So my guess would be 7 billion square feet. It's a lot. In 2016, the Burj Khalifa was the tallest building in the world. It was very expensive to build. You don't say. Consider the question. Which is taller, the Burj Khalifa or a stack of money it costs to build the Burj Khalifa? Ooh. So what information would you need to be able to solve the problem? So you need to know how tall, the height of the building, and the thickness of a bill. Like money bill, right? Record the information your teacher shares with the class. Oof. Oops. Well then, let's not worry about this portion. La 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 la. Bro, are you serious? Powers of 10 can be helpful in making calculations with large or small numbers. For example, in 2014, the United States had 318,586,000 495 people who use the equivalent of 2,203,799,778,107 kilograms of oil and energy. It's a lot of oil. The amount of energy per person is the total energy divided by the total number of people. We can use powers of 10 to estimate the total energy as 2 times 10 to the 12th, and the population as 3 times 10 to the 8th. So the amount of energy per person in the US is roughly 2/3 times 10 to the 4th of kilograms of oil and energy. It's a lot of oil. Wow. 7,000 kilograms of oil. In general, when we want to perform arithmetic with very large or small quantities, estimating with powers of 10 and using exponent rules can help simplify the process. Key word here, estimating. If we wanted to find the exact quotient of these two numbers, then using powers of 10 would not simplify the calculation. So looking at the homework, which is larger, the number of meters across the Milky Way or the number of cells in all humans? Explain or show your reasoning. So here's some important information. Milky Way is about 100,000 light years across. There's about 37 trillion cells in the human body. And 1 light year is about 10 to the 16th meters, okay? So let's ask the number of meters across the Milky Way. So the total would be how many meters? This is how many meters per light year. So this would be 10 to the 2 zeros plus 3, that's 5. So 16 plus 5 is 21 zeros. So it's 10 to the 21st. Or the number of cells in all humans. So there's 7 billion humans. That's this. And there's 37 trillion cells. So this is 9 zeros. That's 7 times 10 to the 9. And then there's 37 trillion. I know after billions it's trillion. So it's going to be times 10 to the 12th. Now this right here, it's going to be 37 times 7 times 10 to the 9 plus 12. That's 21. So already 10 to the 21. 10 to the 21, but we also have a factor of 37 times 7, which means this is going to be bigger. The number of cells in all of the humans. Now, this question is based off of Unit 6, which is your next unit, so don't worry about not knowing how to do this right now. Ecologists measure the body length and wingspan of 127 butterfly specimens caught in a single field. Draw a line that you think is a good fit for the data. So if you had to draw a line here, how would you draw it? I would draw it something like this right here. So if we had to write an equation, think about it. Where is it crossing? What y value would you say right here? It's about 2, right? So it'd be something like y equals something x plus 2, because that's your starting value. Now, what seems to be the slope? I'm going to go ahead and just say it goes through this point here and this point here. So it goes up by 10 and it runs by 30. So that would be 10 over 30. And what does the slope of the line tell you about the wingspan and the lengths of these butterflies? So since the slope is 10 over 30, for every 10 millimeters in body length, the butterfly's wingspan grows by 30 millimeters. Why did the person throw the butter outside the window? To see the butterfly. Diego was solving an equation, but when he checked his answer, he saw his solution was incorrect. He knows he made a mistake, but he can't find it. Where is Diego's mistake, and what's the solution to the equation? Ooh. So, I would highly recommend you don't try, I don't care if it's backed up, I would highly recommend you do this problem on your own, and Jesus Christ, and then you see where the differences are, okay? So what I'm gonna do right now is I'm gonna rewrite the equation here. And then once you see the mistake, like I'm gonna solve it, but then once you see the mistake, call it out, okay? Negative 4 times 7, that's negative 28. Negative 4 times negative 2x, that's a positive 8x equals 3 times x, which is 3x, plus 3 times 4, which is 12. So let's see. Is anything different right now? Yep. You see? This 8x and this negative 8x. I'm telling you, it's a lot easier if you just try the problem on your own. Oh, they also wanted to solve it? Bruh. Okay, that's fine. So I'm gonna add 28 to both sides. This cancels, so I have 8x equals 3x plus 40. I'm gonna take away 3x from both sides. So that's 5x equals, so 0, 40. Then divide both sides by 5, and we get x equals 8. That's a pretty good x. So x equals 8. Not whatever the heck this is. The two triangles are similar. Find x. Okay. So, they're similar, which means, and I don't think I could do this, but whatever. This corresponds with this angle. This corresponds with this angle. Here, let me use, and this side corresponds with this side. So we know the purples are 46, but we don't know the yellow. We know that the three angles in a triangle add up to 180. So 46 plus 106 is 152. And if we do 180 minus 152, this turns out to be 28 degrees. So x equals 28 degrees. That's it? Really? That was fast. Well, thank you. Please subscribe. Send a like or whatever it is that YouTubers say nowadays.